This is the tutorial for the first part of the problem-solving connections section of Chapter 1. And what the problem-solving connection does is it takes all the material that we've learned so far in Chapter 1 and uses that material to solve a theme-type problem. And today's problem is going to be dealing with raised beds in a garden, and that's what we're looking at here. And so all we're doing to start off with is just trying to find the perimeter of this rectangle. Now again, the perimeter is the distance around the rectangle, and so that's a key word there that we have to understand. And so when we go around the perimeter, we're starting at one point and we go all the way across. So we got 9.5 or 9 1/12 feet, and then we've got a 3.5 feet section, and then another 9 1/12 and another 3.5. And that's what they're going to ask us to do, is find the perimeter. And so what we need to know again is the perimeter. Perimeter is equal to the distance around the figure. So if we're going from one spot all the way around the figure, that is the perimeter. And so if I wanted to find the perimeter, there's a few different ways we could do it. We could first start by taking the length of the side. So we could say the perimeter, P, equals we'll call this the width here, the width plus, we'll call this the length here, plus a length, plus, now that's only two sides. We still have to go around the entire thing. So we have another width that's exactly the same. So we'd have another width and another length. So we could add up all of the sides. That's one way of doing it. And so that would be 3.5 plus 9 1/12 plus 3.5 and plus 9 1/12. So that is one way to find the perimeter. Another way would be, since we have two that are exactly the same, so you have the length and the length are the same and the width are the same, so we can use the rule of multiplication. See, where multiplication is, if we have a repeated addition, we could multiply numbers to come up with that sum faster. And so we can go ahead and take the width and double that. We could take the length and double that as well, and that would give us the same answer. So if I doubled 3.5 and then added that to twice 9 1/12, that would give me that same answer. So that's another way to do it. And another way to do it, the last way to do it, is to see that, well, both of them are being doubled. So remember how I had said before, if I go around the length, or the width, and then the length, I've only gone halfway. I still have to double that expression. So I could take the sum of 3.5 and 9 1/12 and then double that, and I'd come up with that same answer. And that's the method I'm going to use this time. I think it'll be a little bit faster for me, so let's see if it works. So we've got 2 times by, and then I'm going to come up with a common denominator with these two numbers here. So I'm going to multiply that 1/2 by 6 over 6. And so now I've got 3 6/12 plus 9 1/12. And so from that point, I could go ahead and add the two fractions together. So again, I still have the perimeter equals double the 6/12 and 1/12 gives me 7/12. And then 3 plus 9 gives me 12. And so now I just have one multiplication problem. And so when I multiply, I've got to change this improper fraction to or this mixed number into an improper fraction. So we have to start by multiplying the 12 and the 12, and that gives me 144. So maybe off to the side I'd have to write that down, and then I have to add the 7. And so when I add that, I end up with 151. So I have 151 over 12. And then I'm multiplying that by 2. Now I think of the 2 as a fraction, 2 over 1, and then I cross cancel. And so 1 goes in, or 2 goes into 2 one time, 2 goes into the 12 6 times. And now I've got my answer of 151 over 6. But I still want to change that to a mixed number, so I'll do that. 6 into 151. So 6 goes into 15. We have 2 times, and that makes 12. And that leaves me with 3 left over, 31. So 6 into 31 goes 5 times, and that makes 30, and I have 1 left over. And so I'm going to rewrite that as 25 and 1/6. So the perimeter equals 25 and 1/6 feet. Well, then the next question they ask is we have to write the perimeter as a decimal. And so what we're going to end up doing is changing that 1/6 to decimal form. Now, we are going to leave the 25 where it's at because it's going to be 25 point and then something. So that's what we need to find. So we need to figure out what is that 1/6. So I'm going to go 6 into 1. 6 does not go into 1, so I'm going to add the decimal point and bring that straight up and then do the division. 6 into 10 goes 1 time with 4 left over. I was thinking of the 4, and that makes 6 with 4 left over. And I'll have to bring down another 0 and do 6 into 40, and that goes 6 times. Makes 36, and notice how I got a 4 left over again. So what that means is that we're going to always repeat that number that we have in the quotient. So that number is the 6, and that repeats. So I can draw a line over that 6. So my answer is 25.16, and the 6 repeats. And that is in feet. So that's the decimal form. And now moving on to the next question, it says, is the decimal a repeating or terminating decimal? And then is the perimeter a rational or irrational number? So we have to remember the rule with rational and irrational numbers. First of all, a rational number is anything we can write as a fraction. So any number we can write as a fraction. So any number that is a repeating decimal, or a terminating decimal. So a terminating decimal, remember, is one that just ends. So for instance, our 1/6, our 0.16 is a repeating decimal. A terminating decimal would be let's go with 2.5, and then it just ends. See how this ends? There's no number after that. Those are repeating. Now, irrational is something that we cannot. So we cannot write as a fraction. So it is a number in which it does not repeat in a pattern and it does not terminate. So if I had something like 0.16238963226, and then it continues to go on. So notice how there's no number that's repeating in a pattern, there's no value that continues to repeat, there's no series of numbers, and it continues to go on. That's what these little points mean right here. So it does not repeat and it does not terminate. And that's irrational. So, well, what is ours? Well, 1/6, 25 and 1/6 is 25.16 repeating. Since the 6 repeats, it's got to be a repeating decimal, because the 6 repeats. It continues to go on forever. It never ends. And so that's why this is a rational number. So it is a rational number. Well, the next question says the fence costs $1.25 per foot. So whenever we see that word per, that means division. So we're going to use division in the fraction form. That's what this symbol means. See, there's a number up top for this dot and a number down below for that dot. And it's per foot. So that means we've got $1.25 per foot. And so what we want to do is we want to find out how much the cost is. Well, if we want to know cost, we want to know dollars. So we want to cancel out the feet. So what we're going to do is we're going to multiply by the perimeter, by how many feet we have. $25.16, and the 6 repeats. Now, I can't multiply these two numbers the way they are because the 6 repeats forever and ever. If I went ahead and stopped it, it would not be the same number. If I stopped the 6 right after this 6, it would not be the same number. So with repeating decimals, in order to get an exact answer, I need to change this to a fraction. And so that's why we need fractions to be able to solve a problem like this. So these feet are going to cancel, and so I'm going to change this back to the fraction form, 25 and 1/6, and then times by, and I'm going to change this 1.25 to a fraction as well. So I need to change 0.25 to the fraction form. Well, 25 is in, the 5 is in a hundredths place, so it's 25 hundredths, and then I just reduce it by dividing by 25 over 25, and that gives me 1/4. And so from this point, we can go ahead and rewrite that as 1 and 1/4. So now I'm going to change this to an improper fraction. So that's 150 plus the 1, so 151. So I got that by multiplying the 25 by the 6. And that makes 15, or 150, plus the 1 makes 151 over 6. Times by, and then I multiply these numbers, and I get 4 plus 1 makes 5 over 4. Well, there's no cross canceling, so we need to multiply cross. So this makes a 5, 25. 5 times 1 is 5, plus 2 is 7 over 24. So now I need to divide. And so off to the side, I'll do 24 into, and then 755. So I know that 24 goes into 75. Well, 25 goes into 75 3 times, so I'm thinking it's 3, and that makes 72. And then 24 goes into 35 1 time, and that gives me 11 left over, so I have to add a decimal point, and it continues to go on. So I know 2 goes into 11 5 times, but I think that's going to be a little bit too big, so I'm going to go with a 4, so that makes a 16, and carry a 1, so it makes 96. And I do a little borrowing there, and it makes 14, so I'll have another number there. And I know 2 goes into 14 7 times, but I think that's going to be a little bit too big, so I'm going to go with a 6, and that gives me 24, and 12 and 2 gives me 12. Oops, 12 and 2 gives me 4, so let me change that real quick. 12 and 2 gives me 4, so that means it's going to be a little bit too big. So I see that the 6 doesn't quite work, so I'll cross that out. Now, since it's really close, what I think is that it's going to end up rounding to 6, because when we're dealing with just dollars and cents, we always end up having to round the nearest cent. And so that gives me 120, so I'm going to end up with 20 left over. And the next number is going to end up being an, and then I have to add that 0. And the next number is going to end up being an 8. And since that number is an 8, it's going to round that up. So my answer is going to be $31.46. And that is the cost of the fence. Well, those are the types of problems on part 1. Good luck.